When a computer's really fast, it's called HOD or Zorchi, so we like to say we sizzle. Sizzle stands for the Computational and Information Systems Laboratory here at the National Center for Atmospheric Research.
Supercomputers today are really technologically complex. They've got tens of thousands of processors, thousands of nodes, thousands of disk drives, and many miles and miles of cable that tie that all together. They really work as one computer, all connected by a high-speed interconnect fabric. All the processors end up talking to each other, needing to receive data and give data to other processors. Supercomputers are more than just stringing tens of thousands of laptops together. Moving the data between the computers is really one of its special ingredients and is really one of the biggest challenges we have.
We are a facilities lab, but we're also a science lab doing computational science, and we provide educational services designed to get students excited about high-performance computing and to develop the next generation of computational scientists. I'm sitting in front of a Cray 1A from 1977. It was a supercomputer in those days, capable of doing about 80 million calculations per second. By comparison, we're now running computers that are 20 million times faster than that. We're using them to study the Earth's system. That means all the aspects of the planet, including the atmosphere, oceans, sea ice, the land surface, and all the phenomena in those systems, so hurricanes, thunderstorms, glaciers, and how they're calving off into the oceans. All of those phenomena are connected together in one big system. We call that the climate system. That's changing. Everybody lives in a place where either a drought can strike, a flood can strike, you can have a hurricane or a tornado. All these things depend on our understanding of how this system works and what it's going to do next. Computers have allowed us to understand things that we would never be able to understand otherwise. So what we do here matters. The data is really the heart of the operation.
The Research Data Archive is a reference collection of data that scientists use to study climate and weather largely. The archive has about 600 different data sets, more than 11 million files. This library does not have fiction. It's all about facts. We have collections of observations from individual stations and instruments. One satellite will produce more data than all the observations collected on Earth in a day. And then we also have model output that takes all that information and puts it on a grid covering the Earth, not only the land, but also the ocean, not only the land surface, but also levels in the atmosphere, and not only the ocean surface, but levels deep in the ocean. So we're trying to get all the information available so people can study the ecosystems on this planet and how the whole Earth system works together.
We take the data, the numbers that are coming out of these instruments and models, and we process these numbers and write a bunch of code, and then you get a visual representation so you can see something. We turn numbers into pictures because the numerical data can often be quite vast. Software development, I think, is like a big puzzle where you're trying to bring together various pieces and figure out how to fit them together to construct something.
Climate change is one of the most important environmental issues we're currently facing, and we're seeing the repercussions of it now, and they'll only get worse in the future. Being part of Sizzle is really important. This is where a lot of the climate change data is stored, and I can create visuals that help policymakers understand future climate change.
The way we actually represent this is that we have the basic equations of physics, chemistry, and there will be millions of blocks. And at each point, you have to calculate what is the wind, what is the temperature, what is humidity. And so we're talking about making millions and millions and millions of calculations. And if you want to look at how this changes over hundreds of years, there is no way people could do that. We have to do those calculations on the best computers in the world, such as the ones that Sizzle has. It's still amazing to me that just by having coding, we can actually represent to a large extent how the world really functions.